Guys, welcome back to our video series. So we were talking about uh, feedback loops, which are negative or positive. Now, positive feedback loops are when you move from more more and you reach when it's more, you reach to the same item when it's more, or when you move from less and you reach when it is less. So it is still positive. Remember, I told you positive does not mean more. Positive does not mean more, you guys. Positive just means that the direction has not changed. So you are from more to more or from less to less. So it is positive. It is negative when you have moved from more to less. You get, or from less to more when the direction has changed. So let's see, we have two feedback loops here. These will be positive, this is positive, and this is negative. This is negative. So this is reinforcing, the positive one is reinforcing, and the negative one is balancing. So let's see what we get here. The more you get salary, the more you are performing. So we are moving from more. The more you get salary, the more you are performing. The more you are performing, the more you get salary. So you are moving from more to more. So this is reinforcing. Now reinforcing or positive. Now this one is negative or balancing. Why? Because the more you are tired, the more you sleep. The more you sleep, the less you are tired. So you have moved from more and you have reached when it is less. So from more to less, it is, balancing. You can also do that the other way around. So you can move here. You are less tired, you sleep less. You sleep less, you are more tired. So you move from less to more. So it is balancing. The same here. You can move less. You can start with less. The less you get salary, the less you are performing. The less you are performing, the less you get salary. So you are moving from less to less. So it is reinforcing. Good. Now when it is reinforcing, you put the direction like this and you put plus or you put R, the letter R, you put R. And when it is balancing or negative like this one, you put minus or the letter B. But remember to always put the direction of the feedback loop. Now let's have one here, an example. When the birth rate is high, the population is high. When the birth rate is high, the population is high. The more when the population is high, you get more birth. So this feedback loop is reinforcing. But look at this one is balancing. The more population you get, the more death you get. The more death you get, the less population you have. So this is balancing because you have moved from more to less. And here you have moved from more to more. So this is reinforcing and this is balancing. So let's see another example here. Let's see another example here. Good. Now we have different loops. We have different loops. So we have this one here, this one here. We move like this. We move like this. We move like this. You get, yeah, this one loop. You can start from anywhere. You can start from here. You can start from here, provided that you turn this one loop. You get. You see. And where do we have another loop? We can start from here. We have this loop going here, going here. We cannot go here. You follow the arrow. We go here, we come here, and we come here. You get that? And we have this loop here. So here we have three loops. Here is not a loop because this one is not a loop, because when you come here, you cannot continue here. No. This one also is not a loop. When you come here, you cannot continue here because you have to follow the arrow. So here we have three loops. We have this loop coming here, coming here, coming here, coming here, coming here, coming here. This is a loop. And now we have this loop coming here, coming here, coming here, coming here, coming here, coming here. It is balancing. And this other loop. So here we have three loops. So among which we have some which are balancing and some which are reinforcing. Now let's start from, you can start from any item, you can start from here, from here, from here. Now let's start from here. The more you get sunshine, the more you get sunshine, the more you have evaporation. The more you have evaporation, the more you have clouds, and the more you have clouds, the less you have sunshine. So this loop here is, reinforcing, because you move from more to less. So sorry, this loop is balancing. Balancing means negative, because you move from more to less, or from less to more. The more you get sunshine, the more you have evaporation. The more you have evaporation, the more you have clouds. The more you have clouds, the less you have sunshine. Or the less you have sunshine, the less you have evaporation. The less you have evaporation, the less you have clouds. The less you have clouds, the more you have sunshine. So the loop is reinforcing. What about here? What about this one, these loops? So let's start from rain. The more you have rain, the more you have an amount of water on earth. The more you have evaporation, the more you have clouds, the more you have rain. So the loop is reinforcing, because you move from more to more, or from less to less. Let's do it the other way around. The less you have rain, the less you have rain, the less you have amount of water on earth, the less you have evaporation, the less you have clouds, the less you have rain. So you are moving from less to less, so it is reinforcing, plus or R. Now this one is balancing. Why? Because the more you have evaporation, the less you have amount of water on earth, and the less you have evaporation. The less you have evaporation, the more you have amount of water, the more you have amount of water, and the more you have evaporation. So the less you have evaporation, we're moving from less. The less you have evaporation, the less you have evaporation, the more you have an amount of water on Earth, and the more you have evaporation. So you are moving from less to more. So it is reinforcing, or from more to less. It is reinforcing. So guys, it is how uh, this works, and these are assumptions. There's no truth in that. You assume. You, the designer, are assume. And remember, when it comes to assumption, you know, um, hypothesis, assumption are different. We have another example here. So the more we have sunlight, the more we have sunlight, the more we are having sunlight reaching on plant, the more you are having density, and the less we are having, we have, you see, the more we have sunlight, the more we have sunlight reaching each plant, the more we have density of plant, the less we are having sunlight reaching each plant. So this loop, we only have one loop here. This loop is balancing, negative. Now we are going to introduce a notion of delay. Delay, you know, delay. Delay is what you understand, it delays, takes time. For example, here we have a delay here. The number of growing trees, there's a delay. When you have, a tree, it delays before you have plant trees. It delays before you can harvest. So you wait some time. So we have a waiting time. It does not happen, does not occur directly. So a delay is another information you can use to augment your graph. Augmenting a graph means adding more information. The more the planting rate is high, the more the planting rate is high, the more you have the number of growing plant, the more you have harvesting. But there is a delay because there's a waiting time before you can harvest, and the more you harvest, the less you have trees. So this one is balancing. This loop is balancing. But here we have a delay because you don't plant, you don't plant and then it grows directly and you harvest. No, there's a waiting time between the planting and the harvesting. So this is the notion of the delay. So this is translating dynamics system. Translating our causal graph. What we have been doing, our causal graph. Now these causal graphs are going to be translated into stock and flow. You know, stock and flow diagram. So these are the symbol we are going to use for stock and flow diagrams. So once we have this diagram, then we are ready to take it to the machine, to any logic for implementation. And how do you get this diagram? You get this diagram, from the causal diagram. So you guys, let me show you an example. You see, this is a causal diagram, and this is a stock and flow diagram. This is a causal diagram which is translated into the stock and flow. So it is this stock and flow diagram that you take to any logic for programming and simulating your model. So we are going to cover that in the next video. So you guys, I hope you have enjoyed the video. Thank you for watching. Bye bye.